Hi everyone, since we're not having section on Thursday, I wanted to record a quick video going through some introductory R code for people who are not familiar with coding in R. So right now I have a screen capture of what my RStudio window looks like. RStudio is an environment for coding in R. You don't have to use RStudio, and you may decide you don't want to, but I like RStudio and a lot of other people like it as well. So this is, what you're looking at here is a script file. This is a file that you can use to record and save code. And on the screen I have up in the upper left the script file. In the upper right is where my global environment is, and that's where data and objects that I'm working with will be shown. Down here I have the console, which will show code or that I've run. I can also run code directly in the console, although that is not advised because that's not easy to save like your code in your script file will be. And finally, down in the lower right are things like plots, packages, help menu, etc. Okay, so going from, so if you downloaded, let's see, where are we? So if you downloaded this script file from GitHub section 1 dfst, it'll look like this, and you'll see the code with the hashtag in front of it. I don't know what the official name for that is commented out, so that won't run. So if I run this, you can run with Control Enter, or what's the other way to run up here. That's not going to do anything because it's commented out. On the other hand, if I run this line of code, library foreign, that's going to load the package foreign, which allows me to do things like import data that's in a .dta file created by Stata. Okay, so I'm going to walk through, I'm going to walk through a couple basic basic operations. So creating objects, we can use the assignment vector, the assignment operator, which is this, to assign objects. So we can assign x to, or the object x, which is equal to the scalar 5. And if I want to pull it up in the console, x, and it just says 5. I can then assign y as x to the 5th. And then y, I see y up here, it's a value, a scalar, and it is 3125. I can also create a vector using this function combine c, and then I put, so example vector, now I see it up here. I can also make a really large vector, so this means the numbers 1 to whatever that number is, is that a million? And I see that up here as well. Okay, I can also create a vector of characters. So these are strings, combine A, B, C, D, etc. together. And I use quotation marks because I'm telling R that it's looking at characters, not numeric objects. Finally, I can create a matrix. And so the function matrix needs elements in it, and it needs to be told how to put those elements together. So, and I can figure that out by using the help command, question mark matrix. And over here I can look and see, and it tells me what matrix does, and the different arguments of matrix. So the data, and then how the data should be arranged. Okay, And then I can also make a data frame using the command data frame, and I see that up here. Data frames in matrices are pretty similar, although different commands will work for each type, and we can talk more about that. Okay, so if I want to look at an object, for instance, this data frame, I can see it here. I can look at the first 5 rows of it. I can access a specific element in it. So using the square brackets allows me to select the second here element of my example vector. I can look at a subset. I can create a subset of example data frame by selecting the rows 1 through 3, comma, and then if I put comma, nothing, that's just all the columns. So subset data frame is going to be the first 3 columns of example data frame. And I can look at that here. I can look at it down here, etc. Okay, so let's think a little bit about attributes of objects. So I can use the function class to determine what type of object I'm looking at. So the class of example data frame 1 is a data frame. The class of a matrix is a matrix, and etc. for numeric vectors and character vectors. And you can coerce an object into a different class. So I can, for instance, say test as character example vector. Now if I look at test, these are still numbers, but now they're characters, and that's why they have quotation marks. And if I wanted to, for instance, take the mean of test, I wouldn't know what to do with that because these are not numbers; they're strings, characters. All right. So I'm going to comment that out, so because it's not part of the main assignment here. Okay, so we can use the function length to figure out how long our objects are. So remember example giant vector, which was a sequence of numbers from 1 to 1,000,000. That is of length 1,000,000, unsurprisingly. We can also look at the dimensions of our data frames. So example data frame is 6 rows by 2 columns. And if I take the length of that, it's going to give me apparently the number of columns. I can also call particular variables within my data frame. So I can use the function names to provide me with the names of the columns. So here the 2 names are example vector and example vector string. So I can use the $sign here to call these variables within my data frame. So if I call this, it's going to give me that variable within the data frame and etc. here. And I can also ask the length of one of these variables, which is 6. Another thing you can do if you don't want to keep writing $signs is use the attach command, and then I can just R knows that I want to use example data frame, and it's going to look inside example data frame for example vector, and then I have to attach it. Okay, and then so using help is good if you're curious about what a function does. We talked about that before. So for instance, I can do help length, and it will tell me what the length function does and the different arguments, and maybe even give me an example. Let's see down here. Okay, so we can look at some measures of central tendency and dispersion using the summary function. So summary of example giant vector is going to give me the minimum, first quartile, median, mean, third quartile, and maximum. I can take the mean in particular, and I can take the median as well. They're the same here. This is an example of writing a function. I think I'm going to skip over this for now, but you can look at it on your own. It's a little complex. So we can, let's create a new set of data. Let's see what that, which is a number, these numbers. We can create a table. And this is going to tell us how many times each of these numbers appears. So looking for the mode. Here we can write some code to figure out what the mode is from this table. So we're saying we want as numeric of whatever's inside here. We're going to take the names of the table for which it's the maximum amount, appears the maximum number of times. So, and I can run each of these individually to figure out what this code is doing. So this is table equals max table. I can see it's true for 5, and now I'm going to look for the names of the table for which that's the case. It's 5, and then I want to turn that into numeric. There you go. We can also take the standard deviation. Okay, so we're almost here. As I said, enough silly made-up data. Let's talk about real data. So working with real data, the first thing we have to think about is our working directory. So the command get wd tells us where on our computer, where the current working directory is, and that's basically where on our computer R is looking for files. So right now, I'm not where I should be. My working directory is in one of my research projects, but I want it to be in this teaching file, section 1, so I set working directory to this spot on my computer. And the way you can kind of figure out how to call this is if you go to the folder where you want to reference, you can actually do, I think it's different on Mac, you can look it up, shift, right click, and you can copy its path, paste here, and you see what it looks like, and sometimes you have to fix the slashes. So once you've set working directory where your data is, and that's the case for me, we can use commands like read.csv to read in CSV files. So I'm going to read in this data, and you can see here is the data, csv.example, 16 observations of 5 variables. I can look at it here. We can also read in .dta files. You can save files. I don't actually do this very often. Normally I'll just save my R script, which I run from importing data all the way down to my analysis. But this is one way to save data. And you can also write data files out to CSV using write.csv. Okay. So just a couple more things here. If we want to look at some data from csv.example, I'm going to use attach. So I'm working within this data set. I can use make a histogram, which shows up as a plot down here by using the hist command. I can change the color. I can change the number of breaks in the histogram. I can add a line. I can create a density plot. Anyway, and you can think about some of these questions on your own. So finally, if you want to keep track of what you're done, you can use the ls command to make a list of the objects in your environment. You might want to clean up your environment by removing something, or you can remove all of the objects in your environment. And that's not a problem here, because if I want to recreate all those objects, I can just run all of this code again. It should be pretty quick. And all those objects are back in there. Alright, thanks for watching, and I hope this is helpful.